Hypothesis explains how the solar system was created from a nebula cloud. Discover how this hypothesis theorized about the formation of the sun, the planet, and asteroids.
Stars structure from space, residue, and gas. The Nebular Hypothesis is a clarification for the arrangement of nearby planet groups. Cloud is Latin for cloud. As indicated by the clarification, stars are brought into the world from billows of interstellar gas and residue. The progress from an undifferentiated cloud to a star primarily complete with planets and moons required around 100 million years. As per this hypothesis, our own planetary group formed with regards to 4.6 billion years prior, and others are shaping today in far-off nebulae.
A star is born. A solar system begins when an interstellar cloud containing approximately 75% hydrogen, 25% helium, and traces of other elements begins to form areas of higher concentration at clumps. Eventually, one clump dominates, and when its temperature reaches 10 million degrees Kelvin, 18 million degrees Fahrenheit, nuclear fission begins. The clump of burning hydrogen gas stabilizes and becomes a star.
The results of the collision change the space. The planet that is closer to the center is warmer in temperature and opposite to those that are beyond. The remaining parts of the planetesimals became comets as they get close to the sun.
The idea that the solar system originated from a nebula was first proposed by Swedish scientist and theologian Immanuel Swedenborg in 1734. Immanuel Kant was familiar with Swedenborg's work and developed the theory and published it in his Universal Natural History and Theory of the Heavens in 1755. In this theory, he argued that gaseous clouds or nebulae slowly rotate, gradually collapsing and flattening due to gravity and forming stars and planets. A similar model was proposed by Pierre-Simon Laplace in his theory, Exposition of the System of the World, which was released in 1796. In this theory, Laplace said that the Sun originally had an extended hot atmosphere throughout the solar system.
Reflection nebulae are clouds of dust which are simply reflecting the light of a nearby stars or stars. Reflection nebulae are also usually sites of star formation. They are usually blue because scattering is more efficient for blue light. Reflection nebulae and emission nebulae are often seen together and are sometimes both referred to as diffuse nebulae.
Reflection nebula. A reflection nebula differs from emission nebula. It does not emit radiation of its own. It is a cloud of dust and gas that reflect the light energy from a nearby star or group of stars. Reflection nebulae are frequently the site of star formation. They usually tend to be blue in color because of the way that the light is scattered.
Dark nebulae are clouds of dust which are simply blocking the light from whatever is behind. They are physically very similar to reflection nebulae. They look different only because of the geometry of the light source, the cloud, and the earth. Dark nebulae are also often seen in conjunction with reflection and emission nebulae. A typical diffuse nebula is a few hundred light years across.
Galaxies. Early in the century, there was a great debate as to the nature of the nebula like this one, which at that time could not be resolved into individual stars. Thanks in large part to the work of Edwin Hubble, his famous paper, The Realm of the Nebula, finally put the issue to rest. We now know that these are really vast conglomerate beings of stars, that are very much more distant from the Earth than other nebulae. Our own Milky Way galaxy is just one of the billions of galaxies now known to exist, and a typical galaxy is 100,000 light years in diameter. Globular clusters are gravitationally bound groups of many thousands of stars, sometimes as many as 1,000,000, creating cis-primally of railroad stars. Globular clusters are not concentrated in the plane of the galaxy, but rather are randomly distributed throughout the halo. There are several hundred globular clusters associated with our galaxy. A typical globular cluster is a few hundred light years across. Open clusters are loose aggregations of dozens or hundreds of young stars. They are generally not gravitationally bound and will disperse in a relatively short period of time. Astronomically speaking, they are often associated with more diffuse nebulosity as well, also called galactic clusters, because they are usually found in the plane of the galaxy. A typical open cluster is less than 50 light years across. Emission nebula are clouds of high-temperature gas. The atoms in the cloud are energized by ultraviolet light from a nearby star, and emit radiation as they fall back into lower energy states, in much the same way as a neon light. These are usually red because the predominant emission line of hydrogen happens to be red. Other colors are produced by other atoms, but hydrogen is by far the most abundant. A planetary nebula is shells of gas thrown out by some stars through the end of their lives. Our Sun will probably produce a planetary nebula in about 5 billion years. They have nothing at all to do with planets. The terminology was invented because they often look like little planets in small telescopes. A typical planetary nebula is less than 1 light year across. Supernova occur when a massive star emits nebulas in base of Mars. In a few days, a supernova emits as much energy as the whole galaxy. When it's all over, a large fraction of the star is blown into space as a supernova remnant. A typical supernova remnant is at most 3 light years across.
Comets, asteroids, and meteorites recovered on Earth also provide a number of clues and evidence of nebular-type development, and the motion of the most solar system objects orbit and rotate in an organized fashion.
In conclusion to the solar nebular hypothesis, our solar system formed out of the remnants of a nebula that condensed into the Sun, planets, and moons that later our solar system. The orbital plane of the planets and moon is a result from the nebula, which is an interstellar cloud of dust and dust, spinning and spreading out into a flat disk. Intense gravitational pull from the large amount of mass in the Sun caused hydrogen to fuse into helium, creating the birth of our Sun.